Hello everyone. If you are watching this, possibly you may have just seen your name on the SMO Round 2 name list. You are very happy that you qualified for Round 2, and then you are realizing, oh no, I have no idea what that actually means. So here's a quick primer to catch you up to what you should know is going to happen in the SMO Round 2. First of all, the SMO Round 2 is pretty long. It is at least 3 hours for junior and it is 4 hours for senior and open. But it is only 5 questions and they're each worth 10 marks. So why do we get 4 hours for 5 questions? Does that mean that they're going to give us impossible questions? Before we get there, I just want to say that the SMO Round 2 is very hard. But not just in terms of the questions themselves. More often than not, you will feel a little bit cheated by how much you are going to score. And that's because we have this impression that, like our essays or our 作文, that we should be given marks for effort. So I've often heard some of my students sharing that for the first time they went to the SMO Round 2, they said, I wrote 3 pages for this question and I didn't get a single mark. Well, that is how it works. You don't get marks just for writing a lot. Now, most of the questions are going to be problems which will be graded either bottom up or top down. Once or twice, you may have a question with part A and part B, and part A be worth 5 marks and part B be worth 5 marks. But most of the time, they're going to be graded bottom up or top down. And unfortunately, neither of them are going to give you as many marks as you might think. Now, for bottom up grading, as it might suggest, it means that you start from 0 and then it counts up from 0. Meaning that for a particular question, you managed to make a little bit of progress. You didn't solve the whole question, but you definitely did something. Now, usually, if you have only the answer, let's say they ask you what is x, you say that x is 5. Or they ask you which of these 3 is the largest, A, B or C, and then you maybe confirm that it is C. If you just give the answer, it is going to be worth only 1 or 2 marks. 1 mark is usually if, let's say, the answer is more on the obvious side, like, for example, what is x? X is 5. 2 marks maybe if you have to list all possible solutions, and maybe there are 3 of them. If you found all 3, maybe you get 2 marks. Now, you also get marks if you just make some useful observations. For example, in a geometry question, you found similar triangles, or maybe for some number theory question, you found that n is even. You may get 1 or 2 marks. And if you make multiple observations, it may stack to 3 or 4 marks. But these are not method marks. So we know that for, let's say, a 3-mark question in your exam, usually it means there is 1 method mark for step 1, 1 method mark for step 2, and then 1 final answer mark. Now, the SMO and most Olympiads do not work that way, because completing the whole solution is actually the main challenge. Now, if I just wrote down 5 random observations and it happens that 3 of them are correct, now I can't possibly say that that deserves 7 marks even though I have no idea how to solve the question. So it's always possible that you may actually have a question that requires 3 observations in order to get to the answer, and yet they only give you 2 marks for the first observation, 1 mark for the second observation, and 1 mark for the third observation. You might say, what? 2 plus 1 is not 10. But that's really the whole point. If, let's say, that I were to give you a computer, and the computer only has 3 keys, 1/3 of a screen, and a half-functioning speaker, I don't think that would be worth half a computer's price. That's probably worth a few dollars. Right? So if you just give a jumble of observations, don't think that, oh, I discovered so many things, I should be surely getting 8 out of 10. This is not method marks, and this is not keywords like, let's say, a science test where you list out all of these reasons, and if you found 3 out of 4 reasons, you get 3 marks out of 4. It does not work that way. On the flip side, there also will be top-down grading. And this is where you have got a complete solution, fully justified, and so it's 10, and then they start minusing off depending on what sort of errors they find. So a perfect solution, of course, is going to be 10 marks. We're very happy with this. The one good thing about round 2 is that minor typos may not actually cost you anything. So for example, what's a minor typo? If let's say that in your solution you wrote something like x plus y equals to x squared minus y squared, where you actually meant for this to be minus. But if let's say that your next step is actually going to be correct, meaning that what comes after is correct, you just miswrote one of these, you may not lose any marks at all. So this is also not like your school exams where you lose 1 mark, 2 marks, half marks for forgetting units, for forgetting this and that. If you make typos, which would be, let's say, x became y, y became x, plus became minus, it may not cost marks unless it is going to be a typo that carried on throughout, all the way until your final answer is also wrong. So this 8 marks could be just wrong answer, but everything else is correct. So your whole logic is correct. You have actually managed to prove everything that you're supposed to prove, but then you accidentally wrote down the final answer wrongly by, let's say, forgetting a plus sign, or maybe making a calculation error. Another way that you may lose some marks is that you missed out one case or one possibility. So for instance, maybe you actually considered x to be greater than 0, but then you forgot the negative case, and maybe the negative case is actually a little bit different from the positive case. That may cost you a bit more marks if, let's say, the negative case is actually important. Now this does not mean that as long as I anyhow glue together the start and end of the question, I'm also going to get 6 marks at least, if there is a logical error. Because if you make a serious logical error, like let's say from A you get to B, and then from B you got to C, you got to D, but actually this step is wrong. Now you may actually just get nothing, because maybe B to C is actually the entire question. So if you just jump from B to C, and that's not true, then the whole question's point has been missed. So this is a little bit on just how your grading is going to go, but I think we also need to see some actual examples. Those of you who are new to the SMO Round 2 will probably find that this is not exactly what you expect, but also it is not as scary as you might expect. Just a quick note, these questions are all from the SMO Junior, because if I were to be explaining 5 SMO Senior or open questions, this video would easily be 2 hours long. And I think you have watched enough 2-hour videos from me in the last few days. So 5 types of questions in the SMO Round 2. Now the first type, which is most common in Junior, at maybe the first question. So for especially the Junior first question, it's just like a round 1 question where it asks you to give a bit of workings. Now this was from, I believe, 2016, the first question. And if you've done a lot of round 1 questions, you might say, hey, this is actually quite easy. And you are right. The way that we do this is normally to just write down that this is a square, and then after that complete the square. Write this as a difference of squares, and then after that factorize. Now 109 is prime, which means that it is just going to be 109 and 1. And so if we solve this, we add them together. 2n plus 12 is 110, n plus 12 is 55, and n is 43. If you did this, this is the perfect recipe for getting something like 6 to 8 out of 10 marks, depending on how much you wrote here. Why is this 6 to 8 out of 10? Because this is actually not the correct answer, and proofs should have some words inside. Now, even though we know what is being said here, that's because I'm talking out loud. If someone is reading this, they might ask, where did M come from? So, add in some helping explanations. So write down, let n squared plus 24n plus 35 be equals to m squared. Because it's a square. And what is m? Where m is a non-negative integer. You can then continue on with the next few steps. You don't have to add words for no reason. Just complete the square, shift it over, factorize. Of course, now what you have to do is not going to be to just add a lot of pointless explanation. What you need to do is to realize that there's actually something we have missed. So we still can say 109 is prime. First thing is to say that that means that n plus 12 plus m can be equal to 109, and n plus 12 minus m is equal to 1, since your m is greater than or equal to 0. So that's why this is larger and the other one is smaller. But the more important thing is that m is a non-negative integer and can be negative. And so there is the other case where it is negative 1 and negative 109. Now this is actually going to be the other solution you have missed that would cost you a couple of marks. So you may lose a couple of marks because you didn't mention all of these things clearly, but also the answer was wrong. The answer was wrong because it's not complete. If you add them, you get 110 or negative 110. And so n equals to 43 or negative 67. So you realize that this is still like a round 1 question, but you need to show your workings a bit more clearly, and more importantly, make sure that since the round 2 questions do not need to have positive integer answers, you do not forget some silly things like 0, fractional answers, negative answers, and things like that. So this is the first thing, the first type of SMO round 2 question. It's just like round 1, but now you need to show some workings. Second type are questions where when you first see it, you have no idea, pretty much like the cute little guy on our video thumbnail. What exactly is going on? This was from the 2019 Junior Round 2. And the key word that I've written here is to experiment. Why do you think you're given 3 to 4 hours? I like to think of the SMO Round 2 and such questions in general as like a mathematics lab. In your schools, you have either got science labs, or maybe you have separate physics, chemistry, and biology labs. You have computer labs. But does math need a lab? Well, a mathematics lab would be a question like this, where you can experiment and play around at no cost. You do not need to wash a test tube. You do not need a petri dish. So in this question, you are told that Aming can either merge several piles into a single pile or divide a pile with an even number into 2 equal piles. And the challenge is it possible to divide this into 315 piles of 1 marble each? If you have no idea whether the answer is yes or no, then we are in the same boat. When you first see the question, when I first see the question, how am I supposed to know? So we should play the role of Aming here and just experiment. So obviously at the start, you cannot divide a pile into an even number of marbles, and so you just have to merge several piles. So at the start, either you merge all of them, that's obviously a dead end. Or you can merge the first two and leave the third. Right, so this is 196 and 119. You can merge the first and third. This is 200 and 115. Or you can merge the last two. So this will give you 81 and 234 as your 2 piles. Now if we take a look at these here, obviously we know that now there is an even number, so we don't have to merge this. We can divide it into smaller piles of, let's say, 98 for the first one, 100 for the second one, and 117 for the third one. So we can continue on with our experiment. Now I see a lot of these here, but out of these, the last one, I can see that they're all odd. So that's the one where at least there's only one possibility to check, which is that I merge together the first two, or the first and third, no difference. And then after that, 198 would need to be split into 2. That's the only move. And then after that, you can merge together 99 and 117. And I'm sure you're getting the sense that we're not making a lot of progress, are we? But that isn't necessarily a bad thing. You see, we are not making a lot of progress towards getting 315 piles of 1. That doesn't mean we are not making progress towards solving the question. You see, as we start doing this, we should pay very close attention to what is going on. Don't experiment for a while and then say, whoops, I give up. Experiment for a while and try to see anything interesting that would make the answer yes or no. So it could be interesting ways to progress towards more piles. It could be interesting reasons why it cannot all become just 1 marble each. If we look here, we realize potentially that in this entire row at the bottom, everything I've written so far are all multiples of 9. right? All of these numbers are multiples of 9. So it will stay as multiples of 9 when you split it in half or when you merge it. And so therefore, it will never ever give you piles of 1 marble. And once you realize something like that, you look around and say, wait, is there something else like this as well? And indeed, you will see that this one here would give you multiples of 5. And this one would give you multiples of 7. And so, none of them can ever get to a stack of 1s because you either are stuck with multiples of 7, multiples of 5, or multiples of 9. So the answer would be no. If you then ask, how do I write the solution? You write precisely this, except that you will need to write down what I have said out loud in words. So just say that at the very start, there are 4 options. Either merge all 3, merge the first 2, merge the first and third, or merge the last 2. And then just explain why each of them doesn't work. In the first case, you can't do anything. In the second case, all the piles will always have a multiple of 7 marbles, then the third and the fourth similarly. So just write it down. It doesn't need to have equations to be a proof. It can just be mostly words and mostly explanations. The third type of question is the sort of problem where it's not that hard, but everybody ends up with something like 5 out of 10 and gets very annoyed. Now, in practice, you don't know that you got 5 out of 10. When I was a student, the SMO scores were released in full, so we knew exactly what we got for round 1 and what we got for round 2 and exactly what was the cutoff. And so if let's say that we said, I solved 3 questions in round 2, how come I only got 25 marks? So most likely it means that one of your questions got 5 out of 10, right? So this is when you would have gotten some insight. Right now you wouldn't know you scored 5 out of 10, but you still would know, let's say if you solved 2 questions in round 2, you expected that I should get a gold, how come I still got a silver? Probably you lost some marks. Now I recall that my students, this is also back in 2016 or 17, my students shared that, oh, there was one question in the round 2 that is just like a primary school question. So I was pretty curious, I took a look at it. And then I realized that this is actually a little bit sneaky. It's a little bit sneaky because it is like a primary school problem, but we need to make sure that we are very careful. The question says determine the minimum number of lines that can be drawn on the plane so that they intersect in exactly 200 distinct points. And so my students at that time told me that, okay, we just have one line is 1, then one line has 0 points, 2 lines has 1, then after that there's 1 plus 2, 1 plus 2 plus 3, and so on. And so I just continue writing down until I get 200 or more, right? So it continues, say, okay, so when you get to 19, you get 19 times 20 over 2 is 190. 20 lines, you get 20 times 21 over 2 is 210. Of course, what I've written here is the sum from 1 to 19 and 1 to... Sorry, I should be writing 20 and 21, right? So, yeah, the sum from 1 to 19 and the sum from 1 to 20. So he said that, okay, it means that the answer is 21. Now this, I believe, got him 5 out of 10. Of course, he tried to explain it properly in words like, okay, every time you add a new line, you add how many intersections. Did you deal with that exactly? I asked him. And apparently the answer is that he did not. And that's why you end up with 5 out of 10. Now you see, it says the minimum number of lines, and so it is actually okay to say that I claim that the answer is 21. But in order to claim that the answer is 21, there are two components. Why isn't 20 enough? Is one component. And how do I use 21? Is the second component. Now we realize that these two are not exactly the same statement, right? Because just being able to get more than 200 doesn't mean you can get exactly 200. So there are two things that we want to say. And basically what my student had written on the left is only just answering the first part. Why isn't 20 enough? Now you want to write that down and say that if there are at most 20 lines, then the number of intersections is at most 20 choose 2, because each pair will give you at most one intersection. So at most 190. Now this explains why at least 21 are needed. Now if this is the SMO round 1, many of you would just write down 21 and be correct. But it's correct because there is a way to get exactly 200. How do we get that? Well, you don't have to draw it all out, but you do need to describe it. So 210 has 10 extra. Now how do I get rid of 10 from here? Well, using 21 lines, one suggestion to get 200 intersections from 21 lines, what I'm going to do is to draw 10 pairs of parallel lines. So that each pair I lose one intersection. Now we have to mention there are 10 different directions, otherwise 10 pairs could mean 20 parallel lines. We also have to mention the other line, right? So draw one more line not parallel to any of these. Does that guarantee that I have 200? Well, I also need to make sure that no three lines coincide at a point like this. Otherwise, I actually lose more intersections that I didn't intend. So I just say ensure no three lines are concurrent. Now you don't actually need to draw them, but you just need to describe it and make sure that you describe clearly what are the conditions that would allow you to get these 200 points. So of course, then we would get 21 choose 2 minus 10 equals to 200 points exactly. Okay, so don't forget that many of these problems have two parts, even though they don't literally split off into part A and part B. Now, the fourth question, the fourth type, would be some questions just have a really clever explanation, which if you figure out, you just kind of feel very satisfied. It's just really, really gratifying. So in this question, this is I believe from 2017, a square is cut into rectangles which are not squares, such that the sides of each of the rectangles are parallel to the sides of the square. meaning that you do not need to worry about, okay, what happens if I just divide them in some weird rectangle? No, that's not going to happen. For each rectangle with sides AB and A less than B, compute the ratio A over B. Prove that the sum of these ratios is at least 1. Okay, so as an example, let's say that I just took a square and I just cut it into half. Or maybe not half, let's cut it like, let's say into this is 1/3 and 2/3. And then the whole thing is 1. So the ratio 1/3 over 1 is just 1/3. 2/3 over 1 is 2/3. So obviously this sums up to 1, which is at least 1. We could also chop it up in some cleverer ways, like maybe I just want to divide it like this. And say for instance that this is 1, 2 and 1, this is 3 and 1, this is 3 and 1, this is 4, let's say. That means that this ratio would be 1/4, this would be 2/3, this would be 1/3, and this would be 1/3, and you add them up, the sum of ratios is more than 1, right? It's 1 and 7 over 12, which is clearly greater than 1. So this is sort of the experimental phase, which you definitely have to go through. Try some examples, not as a proof. Examples are not a proof. If you just wrote this down and say that it is obvious, you get 0. Because you want to prove that it is always at least 1, no matter how we cut it. But the examples help you to see things, just like we did in the second problem just now. Now, what I noticed when I drew this is that some of them, let's say 1/3 and 2/3, are actually just the area of the rectangle, right? 1/3 is 1/3 of the rectangle. That 2/3 rectangle is 2/3 of the rectangle. This 1/4 is 1/4 of the rectangle. Now this here, this 2/3 is not 2/3 of the square, right? Because this is actually 6 over 16 of the square, which is less than 2/3. So what you realize is that the area seems to be less than the ratio, and the areas add up to, well, 1 copy of the square. So roughly, I want to say that the sum of ratios is going to be at least the sum of areas, which is at least 1. Now, this is essentially the solution. We just need to write it out properly. Okay. So I'm going to introduce a very familiar acronym to some of you, which is WLOG. And WLOG is short for without loss of generality. Now, WLOG, or sometimes you say without log, assume the side length is 1. Now you might protest and say, wait, who told you that? Nobody told me that, that's why I said assume. But then how come we can assume? Isn't it a proof we are not allowed to assume things? No, so we are allowed to assume things that don't affect the solution. So for example, if I want to explain Pythagoras' theorem, right? I can say without loss of generality, call the sides A, B and C. Who told you they're called A, B and C? Well, nobody told you, but nothing is wrong with calling them A, B and C. So why is it we can assume here? We can assume here because the ratio do not change. if we grow or shrink the square. Meaning that if you say, well, my square has side length 10, your square has side length 1, how do we know that we are solving the same question? Well, if your square has side length 10, and I shrink it down 10 times, all the ratios stay the same. So this is something that we often do when it is convenient. And also when it is actually without losing any generality. Generality means applicability, right? So it has to be still universally applicable. Now, why is this useful? This assumption means that for each rectangle with sides A less than B, I can claim that this ratio, A over B, is going to be more than AB, which is the area, since B has to be at most 1. Why is B at most 1? Because I assume the side length is 1. So that allows me to write this thing down here. Instead of saying what fraction of the square, which is 6 over 16 of the square just now, I can just straight away say this ratio is greater than or equals to the area. And so therefore, the sum of ratios is going to be greater than or equals to the sum of areas, which is equal to 1. And this is 10 marks, right? You're not going to have to write a lot to get 10 marks. Because it's actually clever. And you may get a bit angry and say, I solved 10 questions in the SMO Junior Round 1, the SMO Senior Round 1, the SMO Open Round 1. It took me so long and now you're telling me this is also worth 10 marks. Yes. Round 2 isn't about long solutions. It's not about writing more workings. It's about finding a correct explanation. Now, having said all this, I have to, of course, acknowledge that there are more technical and more difficult questions in the SMO Round 2. This applies to all the sections, including the SMO Junior. So this is not easy, especially as an SMO Junior question. This was from 2019 as well, I believe. However, it is a problem that if you can actually write down the solution, you most likely are not going to lose any marks. Because how do you even explain this by some wrong explanation, get that is more than 10? I don't think that's going to happen. So let me just explain this and you will see what is the reason why you also get 3 hours. So sometimes it's because you need time to experiment. Sometimes it's because it does take a while to figure things out and to write them down. So I want to prove that the left-hand side is at least 10. That means I want to think about what is the smallest possible left-hand side. Okay, so LHS is short for left-hand side. Now, in order for my left-hand side to be small, it means that I would want A to be small for the first term, and AB minus B squared should be big so that the fraction is small. Okay, now you realize that in these two statements that are written down, A appears twice. You want A to be small and you want A to be big at the same time. That is a bit of a juggling act. But B only appears in the second statement. So we can focus first on how big can AB minus B squared become. So we start with that. So first, AB minus B squared, I want to choose B to make AB minus B squared as big as possible. So B is my variable, and for now, I treat A as if it is a constant. And what I do is I complete the square. B squared minus AB. Complete the square would be A over 2 squared minus A over 2 squared, which, if we simplify it, double negative, A squared over 4 minus B minus A over 2 squared. So clearly, this tells me that this is going to have a maximum value of A squared over 4. I haven't decided what is A, but I know that it will have maximum value of A squared over 4 when B equals to A over 2. Okay? And that means that the left hand side is going to be greater than or equal to root 2a cubed plus 3 over this. Root 2a cubed plus 12 over a squared. Okay, so now at this point in time, one useful thing you could do is to actually think, okay, when can this be 10? Because A can be anything. What would cause it to be 10? Now, seeing that you have got a square root 2 here, you would probably guess that A is something to do with square root 2, and with a bit of time, you will realize that actually A equals to square root 2 is going to be the way to get 10. Because square root 2 times square root 2 cubed is 4, and then 12 over 2 is 6, so 4 plus 6 is 10. So when does equality hold, meaning when is it equal to 10? You actually can write this down. Even if you are stuck at this point, this would already give you at least 2 marks here. So that's better than nothing. But let's press on a little bit. We want to get this to be as small as possible. So to get this to be as small as possible, one of the things that you will see a lot in the SMO Junior and Senior and Open Round 2 is using inequalities to prove stuff, not just to calculate stuff or to solve them. So we'll use our AMGM inequality. And how do we use it? We want to make sure that in our AMGM inequality, this should be greater than or equal to something, meaning that it belongs on the sum side of AMGM and the product side of AMGM. Because remember what AMGM says, right? The arithmetic mean. It tells you that if you have a bunch of numbers and you divide it, it's bigger than if you multiply the numbers and you root it. This is what AMGM says. Meaning that I would like this here, this product, to be actually a constant. Something to do with 10. Of course, you're going to have a root, but something to do with 10. And you would like your sum to look something like this. In other words, you would like to view this as the sum of things which have a nice product which doesn't involve A. How do I find a way to not involve A when A cubed and A squared don't match? Well, the beauty of AMGM is that square root 2A cubed and 12A squared, you can try to make it such that the powers balance out. And so I would need 2 copies of a power 3 and 3 copies of dividing by a squared so that they have a nice product. Now, as we can see from AMGM, the average is bigger than the root of their product, means that the sum is greater than n times of that. So n is 5. So it's greater than 5 times of the 5th root of their product. So I know that this looks horrible, but remember, we have actually chosen this on purpose to have the a's cancel out. So the a's cancel out. You have half a to the 6 times 64 over a to the 6. That cancels off. 64 over 2 is 32. 5th root of that is 2, and so this is 10. So write your reason down as AMGM. And equality, as we have already found earlier, was square root 2. For AMGM, equality occurs when all of the things that you threw into AMGM are equal. So the equality should happen if this first thing that I threw in, root 2 over 2a cubed, is equal to the second thing I threw in, which is 4 over a squared. So solving this gives you a equals to square root 2. B is a over 2 equals to root 2 over 2. Bad news, this is quite difficult to solve. Good news, this is quite easy to get 10 out of 10 for if you know how to solve it, because you just need to explain your steps, even though it's very technical. So once again, as we have seen these 5 types of round 2 problems, the first type, you have got some round 1 questions that just require you to explain yourself. These ones, you should try them, because even if you make a mistake, you may still get an 8 out of 10 or 6 out of 10. Second type are those that you can experiment. This is what you should do with your 3 hours or 4 hours of time. The third type are those questions that have 2 parts. Be very careful to try to address both parts, but even if you cannot, at least addressing one part gives you half the marks. The fourth type are those where there's just a pretty clever explanation, and these are the ones where you shouldn't feel too guilty if you miss it. Even asking you to think about it for 1 whole week, you may just not come out with this idea. So it's okay. And the last one are the ones that are technical. And to be honest, if you're watching this video a couple of weeks before the round 2, it's a bit late to get very good with these technical questions. So unless you are familiar with that, it's okay to miss one of these. Now, I'm not writing a checklist that one of each of these types of questions is going to show up. But you want to identify in your mind which kinds of questions are more to your strengths, and also, more importantly, just know that not every question is difficult. This is supposed to be fun, and this is actually a taste of higher level math that you're very privileged to get before university, because most people who don't do Olympiads will only get a glimpse of this when they do university level math. Thank you for watching. This has gone on a bit longer than I expected, but I think it's useful, and yet it's only a primer. This is not a crash course, because for round 2, every single question should be quite different from previous years. So try the questions with the intention of learning the ideas and the style of writing, not memorizing solutions hoping the question will show up again. If you have any questions, leave them in the comment section below. Please like and subscribe. and all the best for the coming SMO.